Today we're going to be looking at section 6-7, factoring polynomials with multiple types of factoring. This is where we put it all together, all the different forms of factoring. Alright, so when it says factor completely, the first step we generally do every time we're factoring is to divide out our GCF. So the GCF here would be a 5. When I pull out my 5, I'm now left with t to the 4th minus t squared minus 12. Now, with the factors remaining, here is our possibilities. If I have two terms left in my polynomial, I'm going to use my difference of squares. It has to be a difference of squares. If I have three terms, I can do the trinomial factoring either with or without the leading coefficient. And if it's four terms, I'm going to end up factor by grouping. So in this case, I'm going to use my x, since there's no leading coefficient, I'm going to use my x marks the spot. What multiplies to negative 12 and adds to negative 1. And when I'm, see, my factors are, how about a 3 and a 4? To make it negative, I'm going to have the bigger number be negative. So I know that the square root of t to the 4th is t squared. So I break that up there. And I'm going to have a minus 4 and a positive 3. Now the one thing that you need to keep thinking about is, are we done? Are we done? And when you continue, if you notice, t squared plus 3 doesn't break down anymore, but t squared minus 4 is a difference of squares. So I can make that t plus 2 times the quantity of t minus 2, and then of course I've got my 5 and my t squared plus 3. So final answer is 5 times the quantity of t squared plus 3 times the quantity of t plus 2 times the quantity of t minus 2. The one big thing to remember is that you make sure every factor is completely factored, or you will get this wrong. Alright, so now going through on number 1, we're going to look at what do we have. I have 1, 2, 3, 4 terms. So when I have 4 terms, I'm going to use my, that's right, factor by grouping. So, group my polynomials, see if we can pull common factors out. I'm going to pull out a 3a squared, and I am left with 2x plus 1. In the second binomial, I'm going to pull out, let's do, how about a negative 12, and then I'm left with 2x plus 1. Divide out my common binomial factor, which is 2x plus 1, times the quantity of what's left, 3a squared minus 12. Okay, I'm noticing that something is not completely factored, and that is right here. So I made a mistake. The mistake was I didn't do my number 1 problem, which was, remember, I'm supposed to always pull out a GCF first, and I did not do that. So let's see if they work out. Let's see, if I factor it now and pull out a 3, then I'm left with a squared minus 4. I've got that 2x plus 1. Let's finish that up and see if we end up with the same thing. This comes down to a plus 2 times a minus 2, and see how that does affect us. All right, the one thing I'm worried about is that, so we have 2x plus 1 times the quantity of 3 plus a plus 2 times a minus 2. Let's erase it all, redo it like we talked about. All right, let's divide out our GCF, and I get a 3. What's left is 6. Nope. Sorry. Is a, let's go with a 2a squared x plus a squared minus 8x minus 4. Okay, so now I'm factoring by grouping. I'm going to pull out another a squared, so I've got my 3, and now I'm going to pull out my a squared, and what I'm left with is 2x plus 1, and I'm going to pull out my negative 4, and what I'm left with is 2x plus 1. So we have our 3 times 2x plus 1 times a squared minus 4. One thing that I'm worried about in the other situation is that you don't factor it completely. So you can pull out that GCF down lower. So our answer ends up being 3 times the quantity of 2x plus 1 times a plus 2 times a minus 2, and we are completed. So yes, it's the same thing. The bigger problem is, are you going to realize that when you are left with 3a squared minus 12, that that's not fully factored down about here? That's why we pull out our GCF all the way at the beginning. So pull out the GCF, just get used to doing it every single time. All right, number 2, I'm going to, step 1, check for a GCF, and I can divide out 5, and what I'm left with is x to the 4th minus 16. So what we have here is, there's my crazy dog. What we have here is what's called a difference of squares. So I'm going to break that up. X squared plus 4 times the quantity of x squared minus 4. Only problem is I'm not completely done. So this still needs to break down to x plus 2 times x minus 2 times x squared plus 4 times 5. All right, moving on. If you want to take a look at the PowerPoint notes, which are a little bit neater, you can pause the recording and write down the notes. All right, next one, number 3. I won't use yellow. I'm realizing it's kind of bright for the video. So let's start with red. Step 1. Why don't you pause the recording and see if you can do these two on your own. All right, now check your work. Step 1, I'm going to divide out my GCF, which is a 2, and what I'm left with is x squared plus 3x plus 7. Since there's no leading coefficient, I'm going to use my x marks the spot. What multiplies to positive 7 and adds to 3? Well, the factors of 7, there's only 2 of them, 1 times 7. There's no other numbers that multiply to 7. So with that in mind, this is what we would call not factorable. Okay, let's continue with the next one. Check your work. All right, step 1, I'm going to divide everything by my GCF. Divide by 3 and an n I can take out. So what I'm left with is 6n squared plus 7n minus 20. All right, so now since it has a leading coefficient, remember I'm going to have to multiply those two together, and I get negative 120. The center one is 7. I'm sure you've kind of struggled with this one. I went right away. I went to my two numbers. If you look at your factors, I didn't start with 1 and 120. I didn't start with 4 and 30. I went right to the middle, 10 times 12. I said, well, that's close. Let me try 9. I tried dividing 9, didn't work. Tried dividing 8, and it worked. And what do you know? It's 8 and 15. So I went to the two factors. I knew it's only a difference of 7 between each other. So I didn't want to go with that 1 times 120. I went closer into the middle of the factors to 10 and 12. All right, to get a negative 120, I would have to have one of those be negative. To get a positive 7, my bigger number will have to be positive. So, and my smaller number will be negative. So what I am left with is 3n. And now I'm going to keep the first term, 6n squared. I'm breaking my 7n into plus 15n and minus 8n minus 20. Okay, so I divide it out. I'm left with 6n plus 15n and negative 8n minus 20. All right, I can divide a 3n out. That was an n squared. And what I'm left with, 3n. What I'm left with is 3n. I'm left with n plus 5. And when I divide a negative 4 out, I'm left with a 2n. When I divide this by 3, I'm left with that 2. When I divide a negative 4 out, I'm left with 2n plus 5. So my final is going to be 3n, the original one, times the quantity of 2n plus 5 times the quantity of 3n minus 4. Don't forget to check your work and see if it multiplies back to what you originally started with, 18n to the third plus 21n squared minus 60. Pause the recording if you need to finish the notes. All right. Number 5, pause the recording and see if you can do this on your own. Now check your work. Step 1, divide out a GCF, and I have an x that I can pull out of everything, so I'm left with xy minus 28 minus 7x plus 4y. The one thing I'm going to have to do now is just kind of move things around because I'm noticing there's no common factor there. So I'll have xy minus 7x minus 28 plus 4y. Alright, so step 1, I'm going to divide out that x out of both, and I'm left with y minus 7. Step 2, I'm going to divide out a 4, a plus 4. And notice I'm left with negative 7 plus y. Well, that means the same thing as y minus 7. The 7 is negative, the y is positive. So I'm just going to rewrite that. Now, what I'm left with is x plus 4 times the quantity of y minus 7 times the quantity of x. Alright, check your work before I erase it. Alright, next one, pause the recording, see if you can finish this one on your own. Now check your work. Step 1, going to GCF. And I can't find a GCF, so I'm going to get started right away. Just factor by grouping. There's nothing I can pull out of all 4 terms. Alright, the first one I can pull out a t squared, and what I'm left with is p squared minus 4. In the second one, I can pull out how about this? A negative 1. What that does is it makes my 4 negative, and it makes my negative p squared positive. Okay, break it down, divide out my p squared minus 4. It's my binomial factor that they have in common, and I'm left with t squared minus 1. Just a reminder, we have a difference of squares, so we have to break it down to p plus 2 times p minus 2 times t plus 1 times t minus 1. And that's it. There's your final answer. Pause the recording if you need to. Take some notes. The biggest thing to remember is that you always have to fully break it down. So step 1, number 7. Once you pause it, practice more. Here we go. Divide it out. Now this is an important one because this actually is pretty easy. Once I divide my 5 out, I'm left with a perfect square trinomial. This is real easy to factor. Now you can do it with x marks a spot and say what multiplies to 9 and adds to negative 6. But I'm noticing a perfect square minus a perfect square. So when I set up my parentheses, I know x and x to get that perfect square, 3 and 3 to get that perfect square. Now, it has to multiply to positive 9 but add to negative 6. How about negative 3, negative 3? There it is. Next one, number 8, GCF. Factor out a GCF. And so the first one, I'm going to pull out an A. And what I'm left with is B minus 2. Now in this one, I can fully break it down to B plus 2 times B minus 2. Now what is the binomial factor we have in common? A B minus 2. What's left is that A, and I have the, oh, I guess I should have written this plus 1. That's all I can do. Let me erase that. Let's take a minute and do this. Okay, so in the first one, we're going to factor out that positive A. And then I'm left with B minus 2. And here, I am factoring out a 1. Actually, I think it's going to work like this. I'm going to break it down like I did before. Sorry about that. 2. Sorry about that. Last problem. So I can pull out an A, and I'm left with B minus 2. Now here, right away, I'm going to have B plus 2 times B minus 2. So I can factor this out, B minus 2, and what I'm left with times the quantity of A plus B plus 2, which ends up equaling I guess it's going to have to be the other way. Let's disregard that last problem. Let's take a look at how my PowerPoint's doing it. So I'm breaking down the binomial factor, and what they're doing is they're actually dividing out my binomial factor here. A plus B plus 2, I was right. Okay, so we're factoring out the binomial factor right here. And what I'm left with is that A and that B plus 2. So I guess it's just plus 1. And I have final answer. There it is. That's the lesson for today.